All right, here we go. Last new thing of the year. So we're dealing with geometric series and summation. The summation key still works, so your sigma key will work. The problem is the ones that are infinite. So we'll get into that. What does that mean? How do you do this? But the ones that are finite, you can still use the sigma key. If you're not enjoying that sigma key, we have a formula. So the sum, of course, uses the capital S. So the sum of however many terms you want is going to be the first term times 1 minus the ratio to the nth power. Divide that by 1 minus your ratio. So, okay, so again, n is the number of terms. It's in there a couple times. A sub 1, of course, is your first term, and r is the ratio, or how you get from term to term. Now, if you want to use your sigma key, you're going to have to write a sub n. So when you use sigma, a sub n goes right here, and then of course n goes from whatever to whatever, right? So whatever you're looking for. So if you don't want to work that hard, then don't do it. But usually writing an a sub n formula for geometric is pretty simple. I'm going to use the formula, and then I'm going to use the sigma key. So if you want to use the sigma key all the time, that's completely up to you. So here we know, obviously a sub 1 equals 2. And our ratio, to go from term to term, 10 divided by 2, so the ratio is 5. And we know that n is equal to 9, right? Because we're looking for the 9th term, so, or the sum of the first 9. So we would have the first term, 1 minus 5 to the 9th, and then, of course, divide by 1 minus 5. Now, when you put this in the calculator, you can type it in this way. If you don't have the fraction key, and you have to be a little bit more careful about that, this has to go first. You do this first because that's what's in the parentheses, and then you multiply by 2, and then you divide by the -4. So make sure you can use your calculator correctly. This is 976,562. For number 2, we're going to find the sum of the first 8 terms. I'm not going to write it all out. You can see what we have. Our first term is 72. We're doing 1 minus the ratio. Negative 36 over 72. Or if we do negative 9 over 18, looks like negative 1/2. So the ratio is negative 1/2. Be careful with your calculator. If you want your calculator to calculate that correctly, the negative 1/2 needs to be in its own parentheses because it's negative. And you know your calculator doesn't do that very well. And then, of course, this is 1 minus a negative 1/2 at the bottom. Or you could call that 1.5 if that's easier to type in the calculator. Now, the calculator gives you a decimal. Just switch it to a fraction. It doesn't always switch back to a fraction, but on this one it does. So if it doesn't switch back to a fraction, write down the decimal. But this would be 765 over 16. Or 47.8125. Don't round that because that is the entire number. On your sigma key, you know what to do. We clearly have to switch this to x. So if you want to try the sigma key, try it on this one, see what you get. The answer is, of course, 9831. If you know you're not going to use the sigma key, then you have to sort of figure some stuff out. A sub 1, plug in the ones and all that, we'll get 3. The ratio is right here, so the ratio is pretty easy to find. And obviously we know our n is 7 because that's the top number. And so then you could use your formula. So the sum of the first 7 would be 3 times 1 minus negative 4 to the 7th, and then divide this by 1 minus negative 4. You get the same answer. You just have to do a tiny bit of work first. With geometric, there's usually less work to do. Then it's a little bit harder to put in the calculator. The numbers are much larger, but there's usually less work. So again, on this one, I would be careful with this when you put this in the calculator. I think I would add some parentheses. I know I didn't write it like that, but just to make sure the calculator understands. So this would be 5,580,120. Little story problem. A lot of times the story problem uses money. So we have a grocery store starting raising money for the school. In the first month, they raised $4,000. Each month, they raised 1.5% more than the previous month. Yikes. I want to find it after 4 years. Okay, sure. We can do that. So our first term is 4,000. I'm just trying to break down what we need. The ratio. I know that it's 1.5%, but we want 100% and that. So this is going to be, so if we think about 1.5 and we move it over twice, and then we want 100% of it plus that. So we want to put a 1 in front of that because we want to have all of it plus 0.015. So that's the trick to this one. And so month to month, 12 months in a year, 4 years, looks like we're doing 48. Okay, it's a big number. This is gonna be a big number. So we have the sum of the first 48 terms. Now, if you want to use your sigma, you're going to have to write the formula. Sometimes it's not worth the extra work. I'm just going to use the formula. So we have 4,000, 1 minus 1.015, and of course this is raised to the 48th power. And then the denominator is 1 minus 1.015. Put that in the calculator. You get $270,260.88. All right. Now we have this whole thing with infinity. And this is more of a calculus sort of topic, which is nice. We'll actually do some. So a series that approaches a certain sum is called convergent. It's actually approaching something. A series that does not have a certain sum, you can't really find the sum. Series approaches either positive or negative infinity, so it just keeps like going on forever and ever. This is divergent. So it's all about your ratio. So if your ratio is less than 1, then it is convergent, which means you can do the problem. So if your ratio is less than 1, and again, we're talking about the absolute value of the ratio, then you can actually do the problem. If it is not, if it is greater than or equal to 1, then it's divergent, and divergent means no sum. But convergent means you can find the sum, and unfortunately, I didn't put the formula on here. So I'll put the formula on the next page. I don't know what happened. I just totally. This formula will be on your formula sheet. So if you can find the formula, meaning it's convergent, which is weird because these are all infinite, right? They all approach infinity. So you can see infinity will be written a few different ways. Infinity can be written with these 3 dots, or you might have infinity on the top of your sigma. There is no infinity in the calculator, so you cannot use the calculator sigma key on any of this. It's just not going to work. So you are going to have to use this formula. Good news, the formula is crazy simple. For something as weird as this is, to find the sum of an infinite amount of numbers, that seems like it should be a super complicated formula. It's really not, though. You take your first term and you multiply that by this fraction, 1 over 1 minus r. And that is it. This only works with geometric. Right, so we cannot do this with arithmetic. That's why we only talk about r, we don't talk about d. So the first thing we have to do is you have to find the r, because if it's divergent, then you're done and you can't do the problem anyway. So here for the r, looks like -6. And again, the fact that it's negative or positive, we look at the absolute value, that's much larger than 1. So this is divergent, which means the sum does not exist, or you can say no sum, or you can just say divergent. It's totally up to you. For the ratio on this one, 24 over 72 is 1/3, 8 over 20, so it is 1/3. So now we can actually find the sum of an infinite amount of numbers. So 72, and then 1 over 1 minus negative 1/3. And then you just get 108. It's kind of strange how an infinite amount of numbers just adds up to a number. For number 8, 5/4 divided by 1, so 5/4. And then we can tell we multiplied the top by 5, bottom by 4. So 5/4 is the ratio. That's larger than 1. So this one is divergent. Or you could say no sum, or you could say both. Up to you. For this one, the ratio is easy to find. It's that number right there. So that's clearly small. So we know this one's convergent. What, I didn't put that up here, but this one was also convergent. And now we can find the ratio, or not the ratio, sorry, the sum, which would be 45. Because if you plug a 1 into that, I'm sorry, you don't need to even plug the 1 into that. This is your a sub 1. That's how I knew it so fast. And then we have 1 over 1 minus negative 0.2. And so we get 37.5. Here again, the ratio is 1/2. So this is convergent, which means we can actually do the problem. And of course, your first term is negative 8/5. And then we're going to have 1 over 1 minus 1/2. So this one is negative 3.2. For as complicated and as abstract as an idea as that is, the easiest formula we have. So this formula will be in your geometric list on your formula sheet for the quiz. Apologize that it's not already on there, but there it is.